Hello everyone, and welcome to day 3 of the PDC Creo workshops. My name is Justin Canrick, President of the American Institute of Aeronautics and Astronautics, at least the current president here in 2016. So I hope you enjoyed my first two videos. First one we spoke about some general sketching tools, how to make basic lines, shapes. Second one we went into 3D modeling, so extrudes, sweeps, and blends. Today we're going to go ahead and show you guys how to make assemblies. So before completing this workshop, I advise you to watch the first two workshops as always. This one's actually going to be a really fun one, you'll see. Okay, so today's overview. We're going to be assembling multiple parts. We're going to be using the relation tool in Creo to assemble those parts. I'll show you how to go back through and actually modify a part, so when something is in assembly to activate certain parts or open parts to assemble them, how to update them in the assemblies. We'll go ahead and show you how to change the color and also the density of parts. This is very useful, especially in an engineering drawing where you have a lot of just gray, making things kind of stand out, make it a lot easier to view. And of course density, you can go ahead and set the density of your material so you can get an accurate estimate for, and it's the next thing we'll be doing, for the center of gravity and also the weight. I'll also show you a really nifty clearance tool to understand how much clearance there is between parts, or if there's any overlap. So it'll help you understand if you've assembled something or modeled it correctly. And finally, my favorite is the troubleshooting poorly designed assemblies. So a little bit of background on this. This stems from my experience as an intern with Lockheed. When I first kind of got into modeling, I was actually as a manufacturing engineer intern, and I was looking for some modeling experience, so I had to model a bracket. It was basically a solid part with no dimensions on it. I had to remake it. And it sounds simple enough, but it turned out that bracket had some pretty wacky things involved. A lot of the holes were incorrectly placed. They were clocked wrong. Some of the sides were at the wrong angles. So it was a really big challenge with going back and understanding what was wrong and how to fix it. And it actually turned out being a great learning experience and really helped me understand the ins and outs of Creo, being able to go back through, go between parts, understand where a hole should be, where it was. So that's going to be at the end of the exercise here. Okay, so with this workshop, there's a few different things you're going to need, so I'll go ahead and show this to you. If you come over to the internet, go to our website, AIAAUCF.com, under workshops and Creo workshops. Now, if you're very observant, you'll see that day 4 is already mysteriously there, yet this is a day 3 video. Well, I had to go back through and make all these videos again because I wasn't able to record them in class. So I kind of did day 4 before day 3, so don't mind that. You'll see everything there on the website. It looks exactly like this. So you're going to go ahead, click on the day 3 files. You'll notice you also need the 5 day 4 parts from below, which hypothetically, when we first did this workshop, you couldn't get to, but now you could. Anyways, that was my little rant on that. I thought it'd be funny. I'm sure someone would ask. Somebody was going to say, well, why is that there? Okay, day 3, open day 3. You're going to see 2 parts, bracket and housing. These are the parts for the end, the poorly designed bracket example. And I just want to be very clear with this. The bracket is purposely designed incorrectly. This bracket is not designed correctly. There's parts that are wrong with it. Don't think that I designed this and I didn't realize that. It's purposely that way. And that's why you can see here I have a how to complete this exercise. Click on that and it'll actually explain to you what I'm telling you now. That basically you can have a part that's been altered and you need to fix it. So I gave you some tips as to what you should look for. And basically we're going to go through and try and work through these. Obviously we won't look at that file there. We'll try and work through it and see if we can find everything that's wrong. And once you finish, or if you're having trouble, click on that folder and solution. This will tell you, with correct spelling, of course, when you see it, it'll tell you what's actually wrong with it, so that'll help you along. And if you look here, you're going to need the 5 day 4 files. So if you go to day 4, and you click on that, we're going to have 5 files here. We have part 1, 2, 3, 4, and 5. Don't use the assembly. We're actually going to create the assembly today. And this is just there in case you decide to do the workshop without having it already assembled. And we're going to assemble these 5 parts together. Something to note here that you can see how it says like part 1 dot part dot 4. Basically, this part at the end is the revision. So every time you save it, it's going to update this to a new number. So obviously I've modified part 1 4 times and saved it 4 times. So just something to keep in mind. So go ahead and pause the video, and I'd like you to go ahead and download these 5 parts and then go over to day 3 and go over to day 3 and download those parts from here as well. So download those few parts, just keep them separate so you don't get them confused. Okay, so if you have those parts, we'll go ahead and get started. So don't open any parts yet. I'm kind of going to give you an idea of what this is going to look like when we're done. So just kind of watch the screen for the moment. I'm going to open the day 4 assembly. It's going to be all of those parts assembled together, just to give you an idea of what it looks like. And as always, you can always unhide the planes and everything. So here's what we're looking at. We have part 1 is this large square aluminum bracket, I guess you can call it. It's basically a square part with a hole through the center of it. And then part 2 right here is the shaft. So it's going to be a shaft that fits into this block. And on top here, hypothetically, this would be threaded. For simplicity, we just kept that as 2 solid parts that kind of sit on each other. Then you have part 3. It's hard to see, that's interior. And let me go ahead and show you something real quick here. And I'll show you how to do this when we actually work on this part 2. I'm going to make a section to show you what those other parts look like. So part 3 right here, part 3 is this first aluminum washer. I have it green so you can see it. You have part 4 is the this little, I guess you can call it a hand knob. Kind of, I guess maybe it look like something that was on a spigot. And 5 is going to be that little washer in there. So just keep that in mind. This is kind of what we're doing. And we'll go ahead and start this from the very beginning, all right? So let me go ahead and close this guy here. So we'll go ahead and let's go ahead and open up part 1. Now I'm assuming that you guys have already finished the other videos, so that's why I'm kind of giving these parts as it is. If you are interested in actually trying to model these parts on your own, if you go back to the website under workshop 4, I should have right here. So right here is the drawing for the entire assembly. So basically, if you open this file, you'll see a fully dimensioned drawing for each part. And you could actually go back and try to create those on your own and then check it against these other parts here. So that's if you want. You don't have to. Those are there just for your convenience. So here's our first part anyways. We're going to go ahead now and start making the assembly here. So what we're going to do, we're going to come up to the top left. And of course, if you get stuck here, just go back and watch again. You can replay as many times as you want. Click New. And instead of a part, now we're going to use an assembly. And we're going to give this a name. Let's call it Workshop _4 _Assemb. And go ahead and click OK. Remember, no spaces allowed here. And move this to the full window. There we go. Now I've got the assembly, and basically what we're going to do is we're going to start piece by piece assembling your part. So before we make individual parts, and a lot of times, when people model it, like model the whole thing, well, the challenge with that, you don't actually get to see how it goes together. And when it comes to making a drawing, you don't get to make a drawing of each individual part, which is why you need to make an assembly. So the first thing you need to do with an assembly is actually start to insert your parts. So we'll go ahead and start with the first part, so this one right here. What we're going to do is come up here to the left where it says Assemble, and click Assemble. So right now it's defaulting to my documents, so I'll bet it'll do the same for you. We're going to go ahead, you can either look on your desktop if you saved it somewhere, so it would be under day 4, and you have your parts here. Or also, if your part's already open in session, which we have, you can find that under in session. So here you can see day 4 part 1 is here because I have it open in the session here. But you can also just go to the desktop and open it like you normally would. So we'll go ahead and just open it on the desktop. Day 4 part 1. Double click that. Alright, so what you're looking at here is your part. It's at this point basically asking where you'd like to place it. As we go along, it's going to have the same prompt that comes up, and it's going to say, how would you like to place your part? It's called component placement. So looking at what we have right now, we have a few different options. We have a lot of tabs here. So placement tab, this is where we're going to show all of our constraints. Constraints are basically what we use to place the object. So if we want to stay up against a certain surface or want it to be a certain height, those will all show up under the placements tab. And properties, if you want to change the name. Move, I don't really use that too often, so I imagine you can move things in reference to something else. Well, anyways, the first part you assemble into an assembly, you need to use a very special option because, as you can see, there's nothing really to assemble it to. So basically, we're going to take this part and assume that is our default location. So to do that, you come up here to where it says automatic, and instead of choosing automatic, we're going to come down to default. And by clicking default, we're basically saying the X, Y, and Z location all come from this part. So we're automatically fixing it in its location, and everything else will be assembled to this one. Now, if you don't do this, your assembly will not be fully established, the relations won't be fully established, and you may have some problems in the future with trying to get all the other parts in. So again, make sure that the first part, and only the first part, is the default. And you'll see that it just says default origin, we don't have to change anything, and just click OK. So there we go. There's our default part there. So let's go ahead and move along. We're going to go ahead and install the second part. So with the second part, you just go back to that assembly and click day 4, part 2. So now that we've clicked that, you can see we have our second part there floating in space, and it's requesting for us to give it a placement. As you can see here, select any reference for auto type constraining. Something I want to show you first is while you're in this window, you can open placement obviously, and now here's your different assembly options. Before you touch those, you can actually move this part around on its own by clicking that center sphere and just dragging it. So you can drag it left, you can drag it right, up and down, left and right, and you can use these the spears, the pieces of the spear to actually rotate it. So I can rotate it around this way or maybe sideways. Somewhere where this can help is, let's say if we have it in this orientation here, when you go to use the assembly tool, sometimes it gets a little tricky. Sometimes it won't quite assemble the way you want to. So it's usually a good idea to try and just locate it pretty close to where you want before you start assembling. So when it comes to assembling any part, you always need to be thinking in 3 dimensions, X, Y, and Z. You must constrain in all 3 dimensions for it to be fully constrained on the part. So usually with a part like this that's circular, I like to go with a hole. I like to center it on holes rather. So what you can do is if you click the shank of this little pin, you'll see that it highlights under set 1 and there's a part, and now it's going to ask you to select a piece in the assembly. So since I've selected the outside of the shank, it's going to expect another circular feature. So if I go ahead and select the second circular feature on the block, just left click, you'll notice that it clicks right to it, and now you can look and see that two of the axes are actually grayed out. So you can't move this horizontally in any of these two directions, only vertically. Now something to note on this, so I'll kind of line it up so you can see it hopefully. If you come under, yeah, it's a little small. I gave this a 30 thousandths gap tolerance between the two surfaces. When you use this constraint tool and you use coincident, sometimes it'll actually come up against one side instead of sitting in the center of the part. So when you're actually assembling things, you need to be very careful about this right here. And I'll actually go ahead and explain that to you right now. So normally, when you click the two parts, you notice I didn't have to actually change this. It'll automatically assume a constraint. So the coincident constraint would be something for, let's say, two parts that sit flush on each other, flat on two surfaces. For a circular part like this, you want to use a different option, and the option you want to use is going to be down here. It's the centered tool. And basically the difference between coincident and center in this case, and sometimes it's not always the case, is centered will actually locate the two axes of the part. So the axis of this one and the axis of the hole in exactly the same location. It'll basically ensure that the purplish colored part is exactly in the center of the block. So when you're assembling things where you're trying with two axes, and especially if you have clearance, you want to try and use that center tool. Some of the other ones, these will be more apparent on flat pieces, which I kind of realize now that I didn't really use anything that was very flat. But parallel would basically be something where you had two surfaces that you wanted to be parallel. So imagine you have one here, and maybe I'll go ahead and just make a block at the end to kind of show you how that works. And what it would do is it wouldn't necessarily hold it to the surface, but it would keep them parallel to each other. So you can move it out and to the left, but you couldn't actually angle the part. So we'll go ahead and just make a part and show you how that works at the end, just so you get an idea of it. Anyways, back to our piece here. So we have our centered, which is good, and it's actually locked down two of the directions, which is wonderful. So for the last direction, we're going to want to mate this bottom surface to the top surface of this block. To do that, you're going to want to come over to the constraints and add a new constraint. So I just clicked on new constraint. You'll see it's set to automatic, which is fine. And we're going to go ahead and click the two surfaces we'd like to be coincident. So you're going to start with the item, which is your part you're working with. In our case, we're going to choose this flat surface. Left click it, and then come down, look at your block. You're going to want to pick this other flat surface. And now in this case, we're actually going to do something a little different. We could use the constraint coincident, which would put those two surfaces right on each other. But if you remember from the original assembly, I actually have a little washer that goes in between. So what we're going to do, instead of coincident, you can go ahead and change that to distance. And with distance, now you can see we have an offset distance. We can change the location of that surface in relation to the second one. So just as to show you kind of as an extreme, if you were to type under offset 1, all right, let's try something. You can actually see it move while the object 5. You'll see that that distance is 5 inches, and you can always see by this little blue arrow that tells you the distance here. I can tell you that the washer that we're installing is 1/16 thick, so you actually set the offset at 1/16. Of course, you can still do math in this, which is really nice. Press enter. So even though it's hard to see, you can actually see that there is a 16th gap between our two parts, which is pretty convenient there. We'll just go ahead and click the check mark now that we're happy with it. And you'll see now we have our two parts are assembled together. So we're going to go ahead and move on to part 3. So we're going to go ahead now, like we did before, up here on the left, and click Assemble. And let's go ahead and choose part 3 right here on top. Now, part 3 is the washer that goes in between the shank and, or pin rather, and our block. Now, if you remember, I set this to have a distance of 1/16. Another thing you can do is you can actually assemble the washer first before the pin, and that'll allow you to let the pin sit on the washer. So let me go ahead and show you how to install this first. So as you see, I clicked the check mark there. Well, when you're done, you always click the check mark, but if you accidentally click it or you need to get back to this, it's a pretty easy process. To get back to modify this part, you just click on it, and of course it takes a little bit to actually highlight it, or you can always highlight it in the model tree. So highlight the model tree or click it, right click, and click the edit definition button. Now we're back to modifying this part. So let me go ahead and show you how to do it the way where you have kind of a space in there, and then I would assemble this in between, and then I'll kind of show you how you'd fix it if you wanted to assemble this portion first. So if we go ahead and take this and take the outer surface of the washer and click the pin, then you can go ahead and move it around on the assembly, and we'll go ahead and now, of course, it automatically went to coincident. We can change that to centered, and new coincident. We're going to go ahead and set the surfaces as flush now. So we're going to click the bottom of the washer, and now to click that surface here, obviously this part's in the way. So what you can do is if you're on top of it and you right click, you'll actually see it'll toggle between different surfaces on the object. So what you can do here is you can come over the pin here and just right click until we get to the bottom surface of that first part, and you can see now it says part 2. We're looking for part 1. So now you can see I right click until it says part 1 surface. That's exactly what we want. You would go ahead and click and then set coincident. And now it's hard to see, but it's actually coincident on the surface. Hit the check mark. So a way to verify this would be to make a section. So if we go to View and Section, so in View, Section, and click the surface, we're going to click one of the surfaces you'd like to make a section through. We're going to try this top one. And we can drag. Eventually we'll reach a point where we actually see the washer in there. Check mark. It's pretty tricky to see, but you can actually see it in there, and it looks like the distance was actually 1/8, so it kind of intersects it. I'll have to go back and change that really quickly. Anyways, to get out this section, just go ahead and unselect. So go to Sections. You notice it's create the section. Right click, and you can either deactivate or just delete the section. So we'll go ahead and deactivate since we're going to need it again anyways. And now we're back to the beginning. So you notice that the gap in between the parts was incorrect. So again, if you'd like to modify the way something's assembled, you can click on the part. So in this case, day 2 part, right click, and go to Edit Definition. And if we come back into the placement, you'll see our two constraints that we have. And we'll bring forward there. If we go to distance, now if we simply change the offset to 1/8 or 1/8 of an inch, you'll see it's moved it up, and you hit the check mark. It'll now be in the correct location. Okay, so let's say then if we wanted to assemble it in the other order and wanted to put the washer in there first, how would we do that? So what we need to do is first unselect all of the relations involved in the parts. So basically, when we did part 3, we had put those constraints on there. If we go in and right click and edit definition, go to placement, and we're just going to delete these, and I'll show you why in a second here. To delete it, you simply right click and press delete. You do the same for the coincident relationship and press delete. You'll notice that now I can fully move it, so I can just move it out of the way over here and hit the check mark. We're going to go ahead now and work on the second part, part 2, edit. So we're going to right click, edit definition, placement, and we're going to delete these relationships. Delete, delete. So I right clicked and delete, and of course now you can move this one out of the way and hit the check mark. Now here's something pretty useful to know about Creo. Basically, when you go to modify an object, it only knows what's above it. And kind of what I mean by this is you can see the pin and the washer. If I go to edit the position of the pin, you'll notice that the washer disappears. Because in the model tree, the pin was installed before the washer. So when I go to edit this one, it doesn't know that the washer exists. So the only way to be able to model or to assemble the washer before the pin is actually to have it in order prior to the pin. So the way you do that is you click part 3, day 4 part 3, left click and hold, and drag it to above part 2. And what you're going to see now is if you go to part 2 and edit definition, you can now see both parts. So go ahead and click the check mark. Let me show you now why this is significant. So what we're going to do is we're going to assemble the washer before the pin so that the pin will sit on top of the washer. So left click on the washer, or you can always locate it in the tree. Right click, and we're going to edit definition. We're going to do what we did before in placement. Here's all of our constraints. It's set to automatic, which is fine. Go ahead and click the inner surface of the washer, and it's going to ask for part in the assembly, so click the inner surface of the square block. Of course, now you've seen it can lock down on the 2 directions, so all I can do is move it up and down. And just go ahead and move it up so you can actually see what you're working with here. We're going to go ahead and add one more constraint, and that last constraint will keep the washer in place on the surface. It's not automatically set distance. You can go ahead and just change that to coincident. And actually here you'll notice that it is located perfectly around the center, even though the first constraint says coincident. It won't always happen like that. Sometimes it does. I like to use centered just in case. So once we're happy, we see that they're assembled. We see it's fully constrained. Click the check mark. So now that we've done that, we'll go ahead and assemble our pin. So to assemble the pin, now we're going to go to day 4 part 2, right click and assemble, placement like we did before, and we're going to first select the pin, and let's go ahead and click the inner surface of that hole. You can see it's located over. Go ahead and just use centered here. We can now drag up so we can see our surface. And we can go ahead and click the bottom of the pin after, of course, change to our next constraint there. So you always have to click new constraint before you change it. If I was here and I clicked it, it would actually change this one. You have to go back and set again. So make sure you're always in a new one before you go and you try and assemble a new part. Click the bottom of the pin, and now you can actually see we have our washer that's sitting on top of the surface of that counter bore. So I'm going to click the washer, and we'll go ahead and set that as coincident. So there we go. And now, hopefully you've caught up. If not, you can go back and rewatch the video a few more times. You go to section, so off to the left is section. Right click on the section and go ahead and edit definition, or you can just activate if that's any easier. So they'll both get to the same place. The edit definition would actually let you modify its location by simply activating it. I'm just opening the section. So I'll go ahead and show you what it looks like. So if I deactivate this section, I can edit definition, and that would allow me to kind of move around the section to where I need. I usually use this just arbitrarily to understand what the part looks like. So you hit the check mark. We'll go ahead and activate the section. So you'll see now we have our washer, our pin right on top. So now will probably be a good time to show you how to change the color of these things. So you're looking at it, and it's kind of hard to really tell what's going on here. Maybe you could if you assembled it. So if you notice before, I already had these parts colored. So if I come over to the left and open part 3, so just right click and open, you'll see it's gray here. I can change the color here, but the challenge is that color will not carry through to the assembly. So usually what you do is you model the part just as it is, and you don't worry about the color. And then when it comes to the assembly, that's where you can start adding color to it. So it just helps with assembling really, and just ease of understanding what you're looking at. So the way you want to do this is first you want to activate the part you want to color. So let's go ahead and try and color in that washer there. So you can click on it, or if you just come over to the left under part 2, you just right click and come up here above open to activate. And what you'll see now, it'll gray out the parts above it. Activate just the one part there. I can now go to view, so view up on the top there, appearance gallery, and if you click down from there, you'll see a whole bunch of colors. We'll go ahead and make this one blue. So the trick here now is it has all selected, or it'll kind of pick surfaces, edges, everything. The easiest way to do this, especially with that part being kind of in there like that, is if you come down to the bottom right and you change it from all to part. And by doing that, now you'll only be able to select parts. So I can color an entire part here. Just have to get in there and actually select the washer. You could do it there, and I believe you can also go here to the left and actually click the part. So once it's highlighted, you can just come over to the center and center click. Looks like I accidentally forgot that it was the other part. So go ahead and just press Control Z. Of course, it won't be easy here. So reactivate the assembly. Let's go ahead and see if we can undo the color here. So it just activated the that little screw there, or the little pin, and we're just going to change it back to the original color. So click the original color, come down to part, and click the part itself, come off to the side, and center click. Very important, you're center clicking after you've selected the part. So let's try this. Let's see if we can do this again. Hopefully we'll get it right this time. So washer, right click, activate that. There we go. This is what we're looking for right here. Now we're just seeing just the part itself. And now we're going to go to view, Appearance Gallery, and let's go down to blue, select just the part, and we'll go ahead and color the washer. Come off to the side and center click. There we go. Now if we reactivate the assembly, and let's come down to the section now right here and activate the section, you'll see the part is now blue, which is what we're looking for. So to go ahead and deactivate the assembly, right click and press deactivate. Let's go ahead and make this some other color too to make it a little easier to look at. Let's make green. Green looks like a cool color. So like before, Appearance Gallery. And I guess it doesn't have the options for it this time, so you can just go ahead and select it. It's pretty obvious to select it. Come off to the side, center click. There we go. Now it's green. It's a crazy color. Alright, moving along then. Let's go ahead and put the next part in, part 4. So coming up again to assemble, part 4. This time, let's go ahead and assemble that washer first, knowing that it has to go on there first. So instead of hitting the check mark, just hit the X. Let's hit the X and cancel. So this time we're going to go and assemble part 5 before part 4. So that, and you'll see where I'm going with it now. So same idea, placement. Let's go ahead and place this in the appropriate, and make sure you click that surface too. You don't want the edge, you want the surface. There we go, and you notice it has a little clearance around it, nice and smooth. Go ahead and center it, just in case. And bottom surface to the bottom surface. Change it from the distance to coincident. And hit the check mark. And while we're at it here, let's go ahead and change the color of that part. So we'll make that blue color again. Come over, find the part, select it once, come off to the side, and center click. Alright, there we go, and let's go ahead and assemble the last part now. So now we're going to go ahead and do part 4. There we go, here's our part. Like before, placement. I'm going to go ahead and select that center and assemble it onto the shaft, or the shank rather. And now go ahead and set another constraint and assemble the bottom surface to the bottom surface here. There we go. And so, sorry, I won't look there, I'll delete this. So we have the 2 coincidents in there. What you can do now is, now it won't let you rotate it now, but if you go and click a new constraint, so a new constraint will actually allow you to see any of the missing links. Normally this is unimportant, the location of this, but let's say you wanted, let's say this surface and this surface to be parallel for some reason, and to be more exact with your assembly. We have now selected a new assembly. You can click that surface and click the second surface, and now we'll have a few different options. First thing we can do is we can set them as parallel. See now that both surfaces are parallel. This is 10 degrees, so the whole thing is going to turn by 10 degrees. But we can also go back to the constraints and change it to angle offset. And from here, we can really set any angle we want. So if we wanted it to be 90 degrees from each other, we can do that. If we want it to be 100 degrees, it'll move it just a little bit. So we'll leave it at 100 and just have something there, and hit the check mark. Now, something to note as well when you're looking at this, up in the left, you always want to make sure that there's no boxes around this. So if you see a box in the top right hand corner, that means that you've assembled something incorrectly, or one of the references for your assembly may be invalid. So you always want to check for those boxes. You can see we don't have any boxes, which means we've done this all correctly here. So I've shown you now how to actually assemble your parts. Now we'll go ahead and show you how to change the weights. So the way to change the weight is to change the density. So to change the density, we're just going to activate part by part and change the density. So we'll go ahead and start with our shank, our little pin here. We go ahead and click the pin, which is part 2, and let's just go ahead and open it. So you've opened that part 2. First, let's go ahead and figure out what density this needs to be. So in this case, why don't we call this a steel part? So let's just use the first thing that comes up here. And of course, we're in English units. So we're going to use the pounds per inch cubed since our dimensions are in inches and our weights are in pounds. 0.284. So if we go back to our part here, what we're going to do now is go under the Analysis tab here. So right next to Model, click Analysis, and we're going to click here on Mass Properties. So we clicked on Mass Properties, and here's our Mass Properties window. You'll notice that the density as a default is set to 1, so we're going to go ahead and set that to the 284 number. So in density, we're going to type 0.284. Accuracy is pretty reasonably high, which is fine. And once you've done that, we'll go ahead and click Preview here in the bottom left. And now you can actually see the mass of the part. Now, that doesn't seem very right to me there. Density is... So this mass is apparently 55 pounds. Right, I remember what's going on here. So this part is actually really huge. So then I'll show you why. So if we go and here's another tool as well you can use in your arsenal. Come here to Measure. You click that and click the bottom surface. And what we're going to do is hold Control now. Holding Control and click the top surface. It'll give you a distance. So this thing is 10 inches tall. And what we can do is, so I unclicked both of those, click Measure again, and go ahead and measure the edge here. And this is just a nice way without having to actually go in and modify the feature to understand it. So if you get the wrong thing, like I wanted the edge here, all you have to do is just click Minimize, close this screen, and just click Measure again, and just make sure you get the edge. So this thing is 10 inches diameter and about 10 inches long, so it's pretty big. So it's not surprising that it weighs 50 pounds. It must be some kind of part for a heavy machinery, a crane or something here. Well, anyways, once you've done that, just go ahead and Control Save, Control S, and we'll go ahead and move along and change some of the other densities here. So maybe we could go ahead and change this block. Part 1, and we'll just call this aluminum. So what we can do here, instead of opening it, we can actually right-click and just click Activate. Instead of actually opening the part itself, we can activate and modify in here. So what you do now is find the density of aluminum. And let's see. It doesn't make it very easy, does it? It's aluminum. It's going to be 167, but that's in pounds, foot cubed. Let's find a pound per inch cubed. Alright, well, since we don't have it, you can look this up online. We'll go ahead and just convert this really quickly. You 1 second here, let me convert this for you. Okay, so go ahead and convert. You just divide it by 12 cubed. You get something around 0.097. So we can go ahead back into our assembly right here. Go to Analysis, Mass Properties, and change that density 0.097. Click Preview. As you can see, the weight is a lot lower, even though it's a larger part, because of course it's aluminum. Go ahead and click OK. And go ahead and activate the assembly. Really quickly, let's go ahead and change the little screw there. Activate analysis, mass properties, and change the density 0.0 and 7. Let's also assume it's aluminum. Preview. This is pretty huge. It's a 6-pound handle, but nonetheless, I guess we're not very realistic here. Something else you can do as well that should work on here, works for me usually. So instead of going to each one individually, what you can do is if you come to where it says model tree, it's that little hammer there to the left, to the right of it there, right here, and you got tree columns. You should be able to find some mass in here. So under type, change it from info, and I think it should be at the problem. There we go, at the bottom, so mass property parameters. And what you're going to do here is you double click on density and click apply and OK. Now you're actually looking at the density of each part. And it's pretty nice because you can go ahead and just modify it right on the spot. So let's say for that part 3, which is one of the washers, we're going to assume it's pretty light, so let's call it 0.008, just for the sake of putting something in there. And just click off to the side, you'll actually see it automatically changes the density. And with the same here, 0.008, and click off to the side, there we go. And just to remind you where I found that, I came to the hammer, and this is basically your settings, and go to tree columns. And from there, we set type to mass properties, and selected mass properties, you just double clicked on the density, which is over here now. To move it back, you can just double click again, move it back to the not displayed list, and click apply. Very useful there. So now that we're in the larger assembly and we've set all of our densities there, we can actually go and analyze the mass properties for the entire assembly. Click preview, and you'll see this entire assembly with the densities we've given it actually weighs 9.71 pounds. So not very bad at all for a big 10-inch by 10-inch square. That's probably larger than that. It's probably like 20 by 20 at this size. So pretty heavy, but this is not really, I guess, very realistic. So you go ahead and click OK. So that tools button up there, actually, that settings is very useful. Something else you can do with this is if we click on it and click on filters this time, this basically shows different things that can show up in the model tree. So what I like to do is you come up here to features and left click features, click apply and OK. Now you can see all of the information you normally get in the part. So like, let's say I wanted to look at the first part and I want to see how the extrude was done. Instead of opening it in this other window to get all that information, which you see here, I'm in the assembly and I can go to part 1 and just click the drop down. And now I have all that same information here. Let's say I wanted to modify the size of the initial square extrude. Go to the extrude 1, left click, and right click. And now, if I come over here to edit definition right here, it'll actually let me edit the original part. So if I change this number, it would change the thickness of the part itself. So that's pretty neat. So other things to keep in mind. Yeah, that one was a pretty big one there. Right, we said we were going to make a kind of a square portion to show how to assemble something to this. So really quick, let's go ahead and make a new part. We're just going to call this extra day 4, I guess we'll move along on that, and click OK. We'll go ahead and just make maybe like what do you think, a triangular piece to assemble in there. So I clicked extrude like we did last time. It's going to ask for plane. Click the top plane. Go normal to the plane. scroll in a little bit because it's going to be way oversized. And go ahead and take the line tool, click the line, and make yourself a triangle, arbitrary shaped. We'll go ahead and set the size afterwards. So, what you guys get here. Once you get here, go ahead and change this to I don't know, 10 inch by 10 inch maybe. So we'll call it a 45-90 triangle. And just to remind you on how I'm putting these dimensions in there, and I'm going to look quick here, I'm sure. If you go to normal and you click on that, and you click on one of the surfaces you like to measure, you left click, come off to the side, and center click. Of course, here it's not going to let me make this because I've already fully defined my sketch with the 2 dimensions on there, and I went through that in the first video, so I'll just delete this. But that's how you create them. So you left click, come off to the right to the left, and center click. So we have our shape. Once we're happy with it, click OK, and we'll extrude this by 4 inches. And click the check mark. There we go. Now let's go ahead to the assembly and click assemble. And we're going to assemble this part, so we're going to have to look in session for it. So I'm going to assemble in session and extra day 4. And there's the part there. So let's go ahead and just assemble onto the surface here. So we have placement. And let me go ahead and show you what parallel does for you. So if you click the surface and the second surface, and you can see it automatically went to coincident, so I can't move it out. But if I change this to, let's say, parallel, now you can see I can move it any direction I want, but you'll notice I can't actually rotate it. So it won't allow me to rotate it this way or like this. You know, I wish I could point to it with my hands, so I can't, so the mouse is the best I can do. So that's kind of how parallel works, and of course you can imagine if I use angle offset, all it's going to do is just change the angle. So if I can make it 10, we're going to go ahead and just use coincident here. We want coincident. And now let's say I wanted this block to be flush with the bottom of the other block. What we can do is new constraint, click the bottom surface of that triangle and the bottom surface of the block. I'm sorry, I keep changing the names here. It's probably confusing you guys a little bit, but I think you get the idea of what I'm doing here. And we'll go ahead and, actually it's already set, so it's coincident. Now you see it's coincident there. And let's say now I want my third dimension, which is this one here. I can go ahead and then set a new constraint for this surface and make those coincident. And now you can see it's fully defined, fully constrained, and I've used coincident relationship to locate it, which is perfect. I click the check, not cancel, of course, the check mark. Okay, so actually looking at this now, it looks like I might have assembled this incorrectly, and it's kind of good that I show you this. So you can see how it's kind of blue. That means that I didn't actually assemble this to the top of the washer. I must have accidentally clicked the surface of the square plate, but pretty easy to fix. Highlight your part, or find a tree, whatever one's easier for you, and edit definition. And this is pretty nice. This is kind of showing how you can troubleshoot. You're going to be using this in the next part. I can assure you that. And we're going to go to placement now. And that coincident relationship, let's go ahead now, and we're going to change it from the flat surface to the surface of the washer. So the easiest way to do this is come over to the coincident relationship to the assembly. So that's the parts assembled to, and just right click and click remove. So I went to coincident, the assembly, right click to remove. And now we come back over, we're going to be a little more careful to actually select the top of that washer. And if we hit the check mark now you'll see we've got a nice assembled portion. Everything lined up pretty nicely. If you wanted to double check and see how this looked, you could always come up here to section and take a section of this part, place it anywhere you want, hit the check mark, And there you go. So now you can see we have your shank going through. Sorry about that. The plate, and if you look very, very carefully, you'll see the little gap I left in there. That you'd always leave that there for when you're doing engineering design for any kind of tolerances or any kind of error in manufacturing. So I'm happy with it. You're not going to have this little rectangular piece on your own. If you wanted to make it, you could, or I guess it's not a rectangle, it's more like a trapezoid, but that's not a big deal. Once you're happy with everything here, go ahead and deactivate the view. Go ahead and just get rid of this other one since that wasn't there to begin with anyways. Just go ahead and delete it. And there you go. There's your part. And you've got some counterbore holes, got some good stuff to assemble in the next video when you look at it. So running right on time here. So let's go ahead and take a break, and we'll go ahead and move on to the other, my favorite incorrectly designed assembly, alright? Alright, so we'll go ahead and get started on the other one. You can just go and close this out, file, close all this stuff out we don't need anymore. And we'll make sure you don't keep everything open, it'll make a big mess. So we're going to go ahead and select the parts now that we're going to use in the SIG bar of the activity, which of course is the incorrectly designed bracket activity. That's going to be under the day 4 folder. Excuse me, not day 4. What am I thinking? It's under day 3. Let's go ahead and open the housing, which is spelled incorrectly. I just realized that. Well, I'll fix that before you guys see it in your files there. So go ahead and change these datas and turn them off. Here is the housing. It's some kind of circular looking housing with some kind of protrusion on it. Who knows? It's going to be a wonky looking thing, but you never know what it's for. We're going to go ahead and make an assembly of these two parts. So it's really fun to call it housing. Let's go ahead and make a new assembly. And let's call this day workshop. Day 4. Make sure there's no spaces and click OK. And we're going to go ahead and assemble this part. Same idea as before. Click the assemble button. You can either go to the desktop or first you click in session. We'll just go to the desktop, day 3. Double click on the housing. And remember from here we want to have this as the default. Okay, now here's where things get fun. Let's go ahead and assemble the bracket. So assemble bracket. Here we are. So we're going to go ahead and work this out. Let's go like we do before. Place it nice and smooth. Now keep in mind I purposely designed this incorrectly, so if you look at it, you can already kind of see what's kind of wrong with this thing, right? So forgive me if along the process you've got to do a little bit of a trial and error with you guys. Just make sure this thing fits correctly. Of course, I know it's wrong, but just make sure that we get it right here. So let's go ahead and try to assemble it. I'd say the best thing to do is probably get it on that surface first. So let's go ahead to placement, click the bottom of the bracket and the top of the housing surface, and we'd like those to be coincident. And go ahead and just drag it over so you get more to where you want it to be. The next thing in the line would probably be the two surfaces here. Let's go ahead and click that vertical surface. After, of course, we click New Constraint on the second vertical surface. And now let's go ahead and assemble onto the last surface there. So, New Constraint, first surface and second surface, and coincident enough, looks like we got a constraint invalid. So basically what this is saying is there's something wrong about this. I cannot have this surface and that surface to be coincident at the same time. So we'll go ahead and just delete this one. Delete that one that's making it valid. And you'll see it says partially constrained. Let's go ahead and hit the check mark here. Alright, now looking at these two parts, I notice we should probably check and see what this angle is in between those two surfaces. So we should be able to do analysis, measure, and click the two vertical surfaces. You can click one, hold, control, and hit the next one. And we can hear 90 degrees. That's kind of what you'd expect, right? Let's go ahead and see what this part here looks like. So let's go ahead, same idea, measure. Let's take that vertical surface, move around, and hold control while you click that second vertical surface. And oh, there's your problem right there. So this part was somehow made with an 89-degree angle instead of 90-degree angle, and that's thus why it won't assemble. So let's go ahead and fix that right now. So like I showed you before, if you get a model tree under the settings with the little hammer, go to tree filter and change the features, turn the features on, click apply, and click OK. So now let's go to that bracket. So I let the bracket here, click that down arrow, and let's go and find that. It's probably the first feature that we're dealing with. Yep, there we go. Click down again. We're going to edit this sketch, so right click and edit definition. Let's go to normal so we can see what we're actually looking at here. And yeah, so here's your problem. It's 90 this way and 89 from the horizontal surface. So let's go ahead and change this to 90. Simple change, right? Let's see if that makes a difference. And so you're going to highlight again, right click, edit definition, and let's go ahead back to placement. So I'll go ahead and change that from distance to coincident. We want this to be coincident. We're going to now create a second constraint, and let's see if we can get this thing to actually assemble now. There we go. Now it actually fitting correctly, which is nice. Click the check mark, and we'll keep moving along with our trouble finding mission here. The second one, which is not so apparent until you kind of turn it, is that this thing doesn't really fit in there right, and it looks like it's just too large. So what we want to do here is figure out what the radius of this sphere is and see how it compares to this one. So you can either go and actually select the feature here, or you can just go analysis and we'll see if it'll give us the radius. Spherical radius is 1.5, and it looks like this cut was kind of made from the center of the sphere. A nice way to check to see how this cut was made is if we just go back to the housing, and let's go figure out where that cut came from. So maybe it's this one. No. Should be this guy right here. This cut here. Let's see, and right click and edit definition. Alright, cool. So I found the one I thought it was, which was extrude 3. Oh, actually extrude 3 looks like the holes, excuse me, so it's the wrong one. It must be one of the other extrudes. Something we can do as well here is we can actually, to figure out where this feature came in, if you see this little thing that says insert here, if you left click and drag this, it's hard to tell because that was one of the holes, but if I move it up pretty far, you'll start to see it actually undoes what's below it. So looks like extrude 1 was that feature then. go ahead and drag this right back down to the bottom. It's pretty useful actually. So as you're moving it up, it's basically hiding everything below it. So the sketches, the blends, all you can see like the bottom part of this isn't there. This is a pretty nice tool with understanding how the part was made as well. So now we figured out it was extrude 1. We're going to go ahead and just edit this definition and see how they made this thing. Sure enough, it came from the center of the sphere and a 90-degree angle, which is good. So now we kind of have an idea what we're working with here. We'll go ahead and we're going to change the radius of this part so that this sits flush. So on the bracket, we're going to go ahead and find that again in our window. It's right here. Let's go ahead and hide this stuff from the housing. It's in the bracket, down arrow. The first extrude is what we're working with, and we're going to right click and edit definition. So this radius is not 1.6, it's actually 1.5. So all I did was I changed it, I double clicked, put 1.5 and clicked the enter, and clicked OK. And now you'll see that we have successfully made it flush with our surface, but now we've got this little issue with the holes. So let's take a look and see what we have here. I can see a little bit of the other hole there, so you can see it's kind of offset. It looks like maybe there's some kind of clocking or something else going on there, but these other holes, these big ones, they really don't seem like they belong at all. So I'm going to think that these were just made by accident. And so if we go to, I think that's extrude 3. Yeah, let's go ahead and right click and delete those. It doesn't look like that was really part of the design here. It was just supposed to sit on top. So taking a look at these holes, it's really hard to tell. So let's get it nice and close so you can see it. And whenever you get over it, you can't actually see it. So I'm going to try and, so here's the bracket hole, and there's the housing hole. And you can see they're off. Now, trial and error, you'd be able to find this out, but I'm going to tell you that there's 2 things wrong with this. Number 1, the clocking is off. And number 2, the location from which the holes are actually placed is off. So the way those holes are created was I created a circle. And then on that circle, I placed the 4 holes at a certain angle from each other. So let me show you how I did that. Let's go ahead and I'm going to open the bracket, file open, just to make it very clear what's going on here. And if I go to extrude 2 and open extrude 2, you'll see what I did here. Oh, it's blue, that's horrible. Okay, well, let's go ahead and try and change this color first anyway. Just click the OK button. Let's come up to view like we did before, appearance gallery. Let's make it like yellow so maybe you can actually see what we're looking at. Come down to the bottom right down here, and click part. Click the part once, come off to the right, and right click. Let's see if we can see it a little better now. Go ahead and open that sketch. Yeah, well, no, the other one's off, so that doesn't make it easy either, but I think you can see it now. So I have a hole here. Even that's hard to see. Oh, you can play with the color. I want you to just trust me here that there's a circle right here. I basically highlight it. It kind of turns green if you can kind of see it. And that circle was dimensioned from the 2 surfaces. And then the holes are on that circle. So you can see it on the circle there. And I clocked them to a certain angle. So let me try one more color. Maybe we can try something else. See if we can get luck with green. I kind of want you to see this. It's pretty important. There we go. You can sort of see that now. So here's the circle they're created on. And in case you're curious how I did this, they have this thing up here called construction mode, which is really useful. So this circle was made in construction mode. Basically, in the sketch, this doesn't have any effect on how you sketch it. So, like if you put a line in there, a box or something else, it would actually extrude the box. It kind of just uses it as construction. You can see it even says the word construction. And the way to do this, and I didn't show it to you before because I can't show you everything. We'll use this circle as an example. If we wanted this circle to be construction instead of an actual circle, what you do is left click it to highlight it. Or actually I think you should be able to so we're going to try and highlight this thing. Right click and click construction. And now it's impossible to see, but there is your construction lines right there. And you should be able to unselect this guy, change it to geometry, and now it's back to where it was before. So basically, if you use a construction line, it'll allow you to do nifty things like this, where I located the circle on a certain diameter circle. The circular hole cuts rather on the circle, and I made this construction line, and these circles are the only things that are actually being extruded. Anyways, the two things that are wrong here is one, if you look here, 0.75 and 8. These should be the same, so this needs to be 0.75. And go ahead and click the check mark here. And let's go back to assembly and let's see how that looks. I kind of give you a hint that there was something wrong as well. So let's take a look. See, now we're getting closer at least. But now you can see it's definitely clocked incorrectly here. The holes are at the wrong angle, and you probably saw it before. It was set to 80, I think it was 85 degrees. So we'll go ahead and fix that clocking. Yeah, they click on the part. I don't know why I make my life so difficult. I could just come over here to the right and click on it, but right click on it and activate. Let's go to the extrude 2 and edit definition. And here's the other culprit right here, 85 degrees. You want to just change that to 90. And you'll see everything kind of moved over. And click OK. And now, if we activate the entire assembly, and that's really important as well too, so you gotta remember you can toggle between your, let's say the housing and the bracket, and then you can go to the assembly. But if you want to mess with things like the assembly, has to be activated in the assembly, obviously. And take a look down through now, you can see it's nice and centered, just what we want. So from here, just some little things I'll point out to you that I purposely did. See, first, you've got that sharp corner there. So I guess they forgot to put the round on there. What you want to do here is, let's see if we can use that analysis tool, top left, and figure out what the radius on that little round is. And it looks like it's 0.2 diameter. So, and obviously you could try this stuff on your own and kind of use this as a video to check your results. So we go to the bracket, we'll go ahead and activate the bracket. And you don't even actually have a feature for it, so let's go ahead and create the feature. So like we did before, let's get the round. And we're going to try for that back corner back here. That one, and we said that this was 0.2. And click OK. And let's see how that looks. That looks much better. There we go. So the last thing we're going to have to deal with now is, and this one is kind of tricky too. If you're looking real close, you'll see that there's some kind of interference there. And now let me show you something that'll help you with this. Instead of having to kind of look around and try to figure out things on here, and it looks like actually that was the wrong round there. So it looks like I made it a little too large. That was the diameter, and this actually that's going to be the radius of the round. So that's actually going to be 0.1. There we go. Sorry about that. So it just changes the round to 0.1. It was giving me radius is what you're changing here by adjusting the round tool, where when I was taking the dimension with the analysis tool, it's actually giving me the diameter. So anyways, to find out if there's any interference between the two parts, you can use a very nifty tool under analysis. If we go to inspect geometry, global interference, and we're going to click this pairs clearance. So if we click that, now we're going to have the option to figure out clearance between two objects. This is very useful. So it's not the entire assembly, so if there were multiple parts that wouldn't work, it's only for two parts. So I can say from the bracket, and we can do here, of course, like before, select from, come down and select part, and I'll take the whole part. So now you say from bracket, and to, you have part selected, the housing. And what you're going to see now is, looking over on the right, you have the volume of interference. It's very small interference, but nonetheless there is interference. So you can see here it'll actually show you what's going on. And from what I can tell, it looks like you have a part that's rounded and a part that's chamfered, and the chamfer is too small. So there's an issue there. So go ahead and fix that. This is pretty useful. So click OK. Let's go and figure out what's going on here. Go ahead and activate the housing. And let's take a look and figure out what that radius diameter is there. So analysis, and let's figure out the radius diameter. So obviously I can't select it as it is. You can right click until you get the surface you want. And it's 0.2 diameter. Again, to show you how I did that, it's pretty useful. We're going to click measure. It's not going to allow us to select it immediately because there's something in front of it. Right click once and just keep right clicking until you get the surface you want, and then left click. So it's 0.2 diameter, 0.1 radius. Let's go ahead and activate the bracket. And here's our culprit right here. And that's this chamfer. Let's go ahead and just delete the chamfer. So right click under the chamfer and delete. And OK. And now we're in the bracket. Let's go to model. And let's add that round. And we're going to round the two corners here. So 1 and 2. And that is going to be 0.1. And you can actually see here by deleting that chamfer, it looks like it deleted the round in the corner here. So we're going to have to actually make a round there as well. So we'll just start with the 2 here. So we have the 2 and click the check mark. And now let's go ahead and fix that other one there. So basically what happened is sometimes when you make a round on a surface, it kind of relates itself to the other surfaces near it. So we had a chamfer on the bottom here, and by removing the chamfer, we must have removed some kind of relation or something that was helping in creating that round there. So all we'll do is just make a new round, and I believe that one, let's get that corner. It's 0.1 as well. So once we're happy, hit the check mark. And let's go ahead and take a look how our assembly looks now. So visual inspection looks pretty good. Everything looks like it's lining up quite nicely. Go ahead and check to see our clearances. And there you go, we have 0 clearance. So what we're showing here is there's no space, but we're not actually infringing on the other portion, the other part like we were before. Now, in reality, when it comes to engineering, you never want to do this. But just for the simplicity of this assignment, I went ahead and set it like this. So in the real world, what you would do is you'd make sure those holes are set. So there's, let's say, 10 thousandths of an inch, so 0.010 between this back surface in the plate and then the other surface in the plate, so that you leave a little space. And you probably do the same out here, but this was just for simplicity here. So you have your part finished now. I know I went a little quickly there. I was trying to keep ourselves on time. I don't want to go too long with you. So you can always go back, replay this. As always, you have that little cheat sheet that I gave you under the what wrong. You can click on this guy. And I'm not actually connected to the internet right now. But if you could get to it, and it looks like it's on my desktop, you'd look at it and it would basically have all of the information on how to fix that assembly. So that'll be it for me today. I hope you learned quite a bit about the assemblies. As always, this information will be online under the workshops on AIAAUCF.com. I know it went a little bit quick there. I want to keep us in a reasonable time here. If you have any questions, of course, I would highly advise emailing the club email, ucf.aiaa@gmail.com. I'm sure one of them could answer for you. Or if you can get to me, I'll put my contact information on the website. My name again is Justin Henrik, and I really appreciate you watching. I hope you enjoyed. I hope you had a great experience with how to do assemblies. Next week, you'll be looking forward to drawings, which I guess I've technically already done, but go ahead and watch that video. It's really great. It'll give you a lot of experience. Have a great day.